You see them everywhere, right? From those incredible wedding videos to high-tech farming, drones have pretty much taken over. But have you ever actually stopped and wondered how these amazing flying machines are made? Well, today we're doing just that. We're going to go from the first digital sketch all the way to its first flight.
I mean, think about it. It wasn't that long ago that drones felt like something out of a science fiction movie. Now, they're totally revolutionizing entire industries. They're out there capturing our most precious memories, literally changing the way we grow food and even helping to keep us safe. Their impact is just huge.
So you've got this little machine, right? And packed inside just a few inches of technology, you'll find these powerful motors, a whole miniature computer, and all kinds of advanced sensors. So, how does all of that come together to do such big jobs? Let's go inside the factory and see the entire amazing process for ourselves.
All right, so every drone's journey starts not on a factory floor, but inside a computer. Its entire life begins as a purely digital concept, meticulously designed on screen, long before a single physical part even exists.
Engineers use this super powerful software. It's called CAD, or computer-aided design, to build a really detailed 3D model of the drone. But here's the really cool part, the simulation. They can digitally test how air flows around the drone at speeds up to 40 miles per hour, making tiny tweaks to the frame to get the best stability and the least drag. And this is all happening before a single screw has been turned.
Okay, so you've got this perfect digital plan. What do you build it out of? Well, for this, manufacturers turn to a total super material, carbon fiber. This stuff is stronger than steel, but get this, it's lighter than aluminum. It can handle all the vibrations from the motors, but weighs almost nothing. It's no wonder this is the same kind of material used in the aerospace industry. With that design locked in and the material chosen, it's finally time to create the drone's physical skeleton. So let's head over to the factory floor and see how it's actually built.
This is where it's all about precision. Big sheets of carbon fiber are loaded into what's called a CNC machine. Now, you can basically think of this as a robot sculptor. A computer program tells a high-speed cutting tool spinning thousands of times a minute exactly where to cut. It cuts out these perfect little channels for wires, exact holes for screws, and the mounts for the motors. And this whole thing is crazy efficient. We're talking a brand new half frame popping out every 3 to 5 minutes.
And the result of all that high-tech carving? Get this, a drone frame that weighs a mere 3.5 ounces. That's lighter than a deck of playing cards, but it's strong enough to support the entire machine when it's in the air. That is just an incredible piece of engineering.
Okay, frame's done. Next up, we need the parts that actually let the drone defy gravity, the brushless motors. These are really the muscles of the machine, and they have to be built with absolute perfection.
So inside each of these little powerhouse motors, you've basically got two key parts working together. First, there's the stator, which stays perfectly still. It's made of thin steel sheets all wrapped up in fine copper wire. When electricity runs through it, it creates this rotating magnetic field. That field then pulls on the second part, the rotor, which is a cylinder with strong magnets, and causes it to spin like crazy. And that, my friends, is what turns the propellers.
So, how fast are we talking? You might want to sit down for this. An absolutely mind-boggling 40,000 revolutions per minute. At that kind of speed, there is zero room for error. The magnets have to be placed perfectly because even a tiny microscopic imbalance would create these destructive vibrations that could literally tear the drone apart in midair.
All right, we've got the skeleton and we've got the muscles. Now for the most complex, most delicate part of the whole thing, the drone's central nervous system. And the heart of that brain is the printed circuit board, or PCB. Seriously, this little thing is the command center for the whole operation. From keeping the drone stable in a gust of wind to navigating with GPS, every single function is managed right here on this one compact board.
Now, putting these boards together is so incredibly delicate, they have to do it in what's called a clean room. It's a special environment with no dust or static electricity, anything that could damage the sensitive parts. On this one tiny board, you're packing in the main flight controller, gyroscopes and accelerometers for balance, GPS modules, the whole shebang.
And to lock all of these hundreds of microscopic components onto the board, they go through a literal oven where it gets up to 460 degrees Fahrenheit. This melts the solder and fuses everything in place. And the craziest part? All of this is happening on a board that's only 2 or 3 inches wide. It's just wild.
Okay, the moment of truth. All our carefully crafted pieces are ready. The frame, the motors, the electronic brain.
Now it's time for the final assembly, where this collection of parts actually becomes a real flying machine. So here we are on the assembly line, and everything starts coming together, step by step. First, the motors get mounted onto the frame. Then the PCB, the brain, is carefully installed on these special rubber dampeners to protect it from vibrations. Then you connect the camera, the sensors, the GPS, pop in the powerful battery, and finally, screw the outer shell together.
But hold on, it's not ready to fly out the door just yet. Nope. Every single drone has to pass a super tough final exam. The flight software gets installed, and every sensor is calibrated for perfect accuracy. They test the GPS to make sure it's precise to within about 3 feet, and only then does it get to take its very first test flight, hovering up to 50 feet to make sure it's perfectly stable before it gets the final stamp of approval.
And once it passes with flying colors, the drone is carefully packed into protective foam, along with its remote, its charger, a battery, and of course, some extra propellers. Now, it's finally ready to be shipped out to its new home, somewhere in the world.
So when you really think about it, it's just an incredible journey, isn't it? From nothing more than a digital file on a computer to a real high-tech flying machine. It's all built on this amazing foundation of precision, power, and some seriously smart electronics.
It really makes you look at the tech all around us a little differently, doesn't it? It makes you wonder, what other gadgets that we use every single day are hiding these same kinds of incredible engineering stories? So the next time you see one of those drones buzzing overhead, you'll know the amazing journey it took to get there. Thanks for coming along with us.